working with double absolute value equations, and in particular we're going to focus on how we can solve this type of equation symbolically. And to solve this symbolically, it has some similarities to what we did in the video lecture before about how to solve absolute value equations symbolically. We want to diverge into two different cases whenever possible. That way we can drop the absolute value symbols and work with linear equations that we were familiar with. And for the first scenario, or the first example, we can take a look at that one. And here I have absolute value on both sides of the equation. And when I say the absolute value of two expressions are equal to each other, there are really two cases that could be happening. The first case is that these two expressions are just equal to each other, therefore their absolute values are the same. When we have that scenario, that's telling me negative 2/5 x plus 1 is just equal to negative x plus 2. But alternatively, just like before, instead of saying their absolute value or these expressions are equal to each other, what could also happen is that these expressions are just the negatives of each other. Therefore, when I take the absolute value, I would still get the same absolute value, even though they are the negatives or opposites of each other. So when that happens, I can say negative 2/5 x plus 1 is really equal to the negative of negative x plus 2. So really the difference between solving a double absolute value equation symbolically versus the absolute value equation we did before is I'm just throwing the negative sign in front of the entire expression instead of just one single number. And the procedure or the idea behind the whole logic is still the same. It's just we're working with more involved expressions to start with. And let's look at the first scenario where we basically are saying the two expressions are equal. And from here we have an expression or a linear equation that we're familiar with. To solve it, the first thing we can do is to move the terms around so that I have all the variables together and all the constants together on the other side. So to get all the variable terms together, what I'm going to do is I'm going to go ahead and add x on both sides. So to do this, I would have negative 2/5 x. I'm going to write out the steps for this one. And I'm going to keep the plus 1. This is equal to negative x plus 2. Over here on the right side, I have negative x and x cancel each other out. That should be what we were aiming for. And negative 2/5 plus x, x is really 1x, or in this case 5 over 5x. Because of this, we can have the result of negative 2 plus 5, which is 3 over 5x plus 1 is equal to 2. And to isolate the variable term, we can subtract 1 on both sides, and we'll get 3/5 x is equal to 1. To get the end result, we can multiply 5/3 on both sides, and therefore I would get x is equal to 5/3 for the first scenario. And this is similar to what we did with linear equation solving. Feel free to write out more steps if it helps you go through the process, especially as you review the notes. And here in the second scenario, we added a negative sign to the entire expression inside the absolute value. So what I will need to do is simplify the right hand side of the equation first, just so I don't have all the parentheses to deal with. And negative of negative x becomes positive x, negative 2, that's what we have. And for the next procedure, it's going to be very similar to what we did, and I personally don't like to work with negative coefficients, so I'm going to add 2/5 x on both sides over here. And to get that, I would have negative 2/5 x plus 2/5 x plus 1. And that's equal to x plus 2/5 x minus 2. So all I did is adding 2/5 x on both sides, and therefore they can be cancelled out, and I would end up having 1 is equal to, same thing here, x is really the same as 5 over 5x, just so I can get a common denominator. and therefore this is 7 over 5x minus 2. And when we're doing this problem, we can go ahead and add 2 on both sides. Therefore, I get 3 is equal to 7 over 5x. To get x by itself, we are going to multiply the coefficient's reciprocal, which is 5 over 7. And as a result, we would get 15 over 7 is equal to x. And these are the two solutions I get based on the scenario I have. And as a conclusion, we can say the solution set is 5/3, 15 over 7. And that's how we solve this type of problem. Let's take a look at another example just so we have a full understanding on what exactly are the steps. So the first thing we want to do once we have two absolute value expressions on either side of the equation is that we want to try to drop the absolute value. And in order to drop it, we're saying either the two expressions inside are just equal to each other or they are the opposite of each other. So the opposite in our process really just means that they're the negatives of each other. And that's all I need to do for the first step in order to separate the two cases over here. And once I have the two cases separated, then that's where I want to get started on solving the linear equations using the knowledge we had talked about in solving linear equations before. So for the first equation, or really for both equations, you'll notice that I have a denominator of 3, and I try to get rid of denominators whenever possible so that I don't need to work with fraction operations as much. And in this case, it's fairly easy to get rid of it. So what I'm going to do is just multiply 3 on both sides of the equation. Here, once I do so, I will get negative 9x plus 6. That's equal to x minus 1. That way I don't have to worry about all the fraction operations. And to solve the variable here, we can go ahead and add 1 on both sides just to combine the variables, to combine the constants. And therefore, I would get negative 9x plus 7 is equal to x. And if I want to get variable terms all by themselves, I'm going to go ahead and add 9x on both sides. And as I do this, I will have negative 9x plus 9x plus 7 is equal to x plus 9x. Therefore, as a result, I will get 7 equals 10x. To get x, I can divide both sides by 10 and get 7/10 is equal to x. This is the first scenario, and the second scenario is if they're the opposite of each other. And to simplify this, I'm going to do the same thing as before, where I'm multiplying 3 on both sides. And as I multiply 3, make sure that you don't lose a negative sign in the very beginning of the right-hand side. So on the left, it's still going to be the same as before. It's negative 9x plus 6. But on the right side, I should have negative of x minus 1. Don't forget to put the parentheses over here because that x minus 1 on the numerator has this invisible group in symbol around it. Once you drop the denominator, don't forget to add it on. And from here, we can go ahead and simplify the right-hand side to be negative x plus 1. Then we can do a similar thing of subtracting 1 on both sides to combine the constant terms, and we would have negative 9x plus 5 equal to negative x. Then the procedure becomes the same as what we did and add 9x on both sides. So negative x plus 9x will be 8x in this case. And to get x by itself, go ahead and divide by 8. We are going to get 5/8 being the solution over here. And therefore, we can say the solution set is 7/10, comma 5/8. And that's how we can go ahead and solve this type of equation.